There's this little bit of magic that happens on our devices every single day. It's the kind of thing that's practically invisible, but it's totally shaping our digital lives. I mean, think about it. How does your email know what's spam and what's not? Or how does your streaming service just somehow know exactly what movie you're in the mood to watch next? It's kind of freaky, right? Feels like some kind of sorcery. Well, it turns out it's not a crystal ball, and it's definitely not a lucky guess. The answer is one of the most powerful transformative technologies out there today, machine learning. And that's what we're going to dive into, what it is, and more importantly, how it actually works. All right, so let's pull back the curtain on the magic behind all this everyday tech. What's the engine that's making all of this happen? Well, believe it or not, it all comes down to a surprisingly simple idea. So what is it? At its core, machine learning is really about one thing: giving computers the ability to learn from data all by themselves. See, instead of a programmer writing out step-by-step instructions for every single possible situation, we just feed the machine a bunch of examples and let it figure out the patterns on its own. And you know what's wild? This idea is not new. Not at all. A guy named Arthur Samuel, who was a big deal in early AI, came up with this definition way back in 1959. So you gotta ask, if the idea's been around for that long, why is it suddenly everywhere? The answer is pretty simple: data. We have mountains of it now, and the computing power to actually make sense of it all.
Okay, so how does a machine actually learn? What does that even look like? Well, it turns out there are a couple of main ways this can happen.
You can basically think of it like this. On one hand, you have supervised learning. Imagine a student with a teacher who gives them a bunch of practice problems and the answer key. That's supervised. On the other hand, you've got unsupervised learning. This is more like giving someone a giant box of Legos with no instructions and just saying, build something cool. They have to figure out the patterns and structures all by themselves.
All right, let's dig into that first one, supervised learning, the one where there's a teacher in the room.
So the key to this whole thing is something called a labeled data set. It's exactly what it sounds like. Let's say you want to teach a computer to spot pictures of cats. You wouldn't just throw a bunch of random animal photos at it. No way. You'd give it thousands of pictures, and for every single one, you'd add a label: cat or not cat. That label, that's the right answer it learns from. And the process for doing this is a lot like how we study for a test in school. First, you do the training. You let the model study a big chunk of that labeled data, like the textbook. Then you got to test it, right? You hold back some data it's never seen before and quiz it. This is crucial because you need to make sure it actually learned the concepts and didn't just memorize the answers. That's the final exam. A really common way to do this is with an 80-20 split. So 80% of your data is for training. That's the homework and the reading. The other 20% is held back for the test. This is so important because it's how you know if your model can actually handle new, real-world situations it hasn't seen before. So where does this show up in your life? Well, a perfect example's your bank's fraud detection. They've trained a model on millions, maybe billions of old transactions, each one neatly labeled fraud or not fraud. By seeing all those examples, it learns the telltale signs of something fishy. So when a weird charge pops up on your account, the system flags it instantly. That is classic supervised learning right there, protecting your money. Okay, but what if you don't have an answer key? What if all you have is a giant messy pile of data with no labels at all? Well, that brings us to the other side of the coin, unsupervised learning. And this one is all about discovery. With unsupervised learning, we're literally just giving the machine that big, unlabeled pile of data. We don't give it any hints. We don't tell it what to look for. Its whole job is to just dive in and find hidden patterns or natural groupings on its own. It's not about predicting a right answer. It's about finding interesting structures we didn't even know were there. And the main way it does this is through something called clustering. It's just like it sounds, grouping similar things together. So going back to that Legos idea, or imagine a mixed bag of fruit. Instead of telling it this is an apple, you just say, hey, sort this stuff into piles that make sense. And based on things like color, shape, and size, it'll start making a pile of apples, a pile of bananas, and a pile of oranges, all by itself. It discovers the categories. And where is this being used? Oh, all over the place, especially in retail. Think about a big online store. They can feed all their customer purchasing data into an unsupervised model, and the model might spit out these really interesting groups, these clusters. It might find a group of late-night snack buyers, or new parent essentials shoppers, or avid gardeners. The store never told it to look for these groups. The algorithm just found them. And now they can create super targeted marketing campaigns for each one.
So there you have it, the two main flavors of machine learning. And they are both incredibly powerful. They're driving all sorts of new innovations. But like any powerful tool, it's a bit of a double-edged sword. You've got all this amazing potential, and then you have some pretty serious risks we have to talk about.
On the plus side, the advantages are just huge. I mean, we're talking about automating boring, repetitive jobs, getting those awesome, personalized recommendations for music and movies, making better, smarter decisions because we have the data to back them up, and even beefing up our security by spotting threats automatically. It's just a massive leap in efficiency and intelligence.
But, and this is a big but, there's a flip side. For one, these models need a shocking amount of data to work well. They can also be what we call black boxes, meaning we don't always know why they made a certain decision, which is scary. And here's the really big one, bias. If the data you feed a model is biased, and let's be honest, a lot of real-world data is, then the model's decisions will be biased too. And that can lead to really unfair and dangerous outcomes.
So where does all this leave us? As these machines get smarter and smarter, what does our future with them actually look like? I think the big takeaway here is pretty clear. Machine learning isn't magic, it's a tool. A world-changingly powerful tool for sure, but still just a tool. And like a hammer, you can use it to build a house or you can use it to break a window. Its impact, good or bad, comes down to us. It depends on how we, the people building and using it, handle the challenges of bias and ethics. That responsibility is 100% on us. Look, this technology is only going to get more and more powerful. The learning is going to get faster and better. So the most important question we have to ask ourselves isn't really about the tech. It's not what can machines learn. It's what should we be teaching them? And that's something we all need to be thinking about.